When observing a scatter plot, often a trend is apparent. Statistics uses a least square regression line to summarize relationships between two variables. Regression line, a straight line that describes how a variable y changes as an explanatory x changes. We often use a regression line to predict the value of y for a given value of x. Least square regression line that makes the sum of squares or the vertical distances to the data points from the line as small as possible.
To find the least square regression line on your calculator, you will first need to clear your memory. Then select Second Zero and select Diagnostic On. Once you are finished, you can fill in your List 1 and List 2 by going to Stat and Edit. Once your lists are filled, you can go to Stat, Calc, and go to number 4, linreg, ax plus b. Go down and select Calculate. You now have your variables to enter into your ax plus b equation. Say you had 5 separate flowers in pots and wanted to see how much they grew if you exposed them to different amounts of sunlight. You recorded how much they grew as their response variable and how much hours they were exposed to sunlight as the explanatory variable. After getting your data, you should insert these values into your calculator. To do this, select Second Zero and turn your diagnostic on. Next, you should fill in your List 1 and your List 2. Then go to Stat, Calc, number 4 linreg ax plus b, and you have your values. To graph the least square regression line, we would use ax plus b. We would fill in the ax plus b from our calculator. To graph it, we would pick two variables of our choosing. We plugged in 3, where x would be, and found out that our y would be 2.4, and then we plugged in 7 and found out that our y would be 7.57. Now these are our new coordinates which we can plot. Now plot these values and then use a straight edge to draw through these points. This line is the least square regression line. The main purpose of the least square regression lines is to make predictions. If you had an x explanatory value, you could plug it into your ax plus b equation to predict your y response value. Now, taking our example from the last data set with flowers, we can now make a prediction of how much a flower should grow by plugging in the amount of sunlight into our least square regression line equation. We could ask the question, if one flower received 8 hours of sun, how much might it grow? We would solve this by using our previous equation for the least square regression line and plugging in 8. By doing this, we would find out that the flower would grow 8.85 centimeters. Now let's do one more example all the way through. Say you wanted to observe the relationship between the amount of time spent studying and the grade on a final. you get this data set. Put these values into your calculator, following the steps that we showed you before. The equation that you should get should be y equals 3.8x plus 74.5. Now having the equation for our least square regression line, we can ask the question, what grade might a student get who studied for 3.5 hours? To find this prediction, plug 3.5 into your equation where x should be. Do this now. We can predict that a student who studies 3.5 hours will get an 87.8 on the final. Do this last example on your own. Say you wanted to observe the relationship between number of sports played and a mile time. This is the data set that you receive. Plug this data into your calculator, following the steps that we showed you before. The equation that you should get is negative 1.1x plus 10.6. Now that we have the equation for our line of least square regression, we can ask the question, what mile time might a person who plays 6 sports play? Try to find this prediction on your own. The answer you should receive should be a 4-minute mile.